Hi everybody, I'm just waiting for all of the attendees to show up. It should just take a couple of seconds. We're going to have Gary Ganella for sure. He's got nice clear skies. Pamela's going to be here. We've got John Boise and Roy Salisbury are going to be joining us. And then whoever else decides to join us. So I'm just putting this live, so it's live now, FYI. So you can get the embed code now if you want, Pamela.
Yeah.
Hopefully Gary will see that it's live. There we go. Sorry, just got to Twitter and stuff to get it all announced.
So welcome to our star party. This is the part of the show where we show you the Horsehead Nebula while we tweet.
Why don't I do that? I'll switch the... Put up the Horsehead Nebula. Oh, there you go. Enjoy the Horsehead Nebula. I love the fact that it's upside down now, because its position in the sky has changed to the point that Gary has to switch the telescope has to get at the Horsehead Nebula from the other way now, right?
Yeah.
And so before it was right side up because just the configuration of the telescope, and now the telescope has to come all the way the other way and roll over to be able to see it. And I guess that's gonna be from this point on, right? What is it? It's crossed. What did you say, Gary? It crossed a certain point, right?
The meridian, yeah.
The meridian of your view, right?
Yeah.
So the meridian is that line that extends from the South Pole to the North Pole going through straight overhead. So everyone has their own meridian.
And mine's better than yours.
It's not like everybody's at the center of the universe.
Exactly.
Okay. I may actually even be able to watch comments here. We'll see. Now, this was posted, Pamela, you posted it and Fraser posted it, but the comments are going to come up on yours, aren't they, Fraser?
Yeah, they'll come up on mine.
Okay.
Yeah.
Then I'll open that up, and hopefully I've only got
VPR. So
the who what?
The URL. So you'll see the URL ending in VPR, and then you know that's the right one.
Ah.
Yeah.
So we see that you're here. Someone asked, is there a link to get full screen mode? If you are watching this online, there should be a button.
There's a little, yeah, so if you're actually watching it live, at the bottom right-hand corner, there's a little square thing, and you click that, and it'll go up to full screen.
I'm trying to figure out where it is. Oh, there it is. Yeah, it's a square with arrows sticking out. I'm trying to remember where my camera is. It's a square with arrows sticking out all the corners.
Looks like little parentheses. Let me know. Okay, good. I have intuition.
So, for those of you joining us who haven't been here before and seen the Horsehead Nebula, this strange image up on the screen right now that has occasional drop-down menus.
Drop-down nebula.
The drop-down nebula.
Gary, you're cheating.
I know. What can I say?
This is the Horsehead Nebula in the middle of the screen and the Flame Nebula off to the right. And the bright star you see is actually the leftmost star if you're in the northern hemisphere, rightmost star if you're in the southern hemisphere, in the belt of the constellation Orion. So this is a bunch of gas being lit up by the bright stars, and where you see the Horsehead, that's where there's actually a dark molecular cloud that's blocking all the light. Yes, the universe has drop-downs.
Thanks, everybody. So my name is Fraser Kane, and I'm the publisher of Universe Today, and we've got, I guess from my perspective, we've got John Boise, Can you wave, John? There you are. And we've got Dr. Pamela Gay there, and we've got Roy Salisbury. Roy, there he is. And of course, last but not least, we've got Gary, which normally we'll see the view from Gary's telescope, but maybe Gary can give us a flash and wave to us as well. Or not.
Yeah. Hang on, I was slewing.
You're slewing, yeah.
Yes. Here we go. This is me.
There's Gary. Hi, everybody. Okay,
I'll
so
go back to the real stuff.
we had big plans. We had a whole bunch of astronomers all lined up, and one by one they informed me of their horrible weather. So, which is kind of unfortunate because tonight, or I guess last night, night before, is the conjunction of Mars. And so this is the closest point that Mars is to us.
Opposition.
Opposition? Oh, that's right, opposition. Sorry, yeah. So it's the opposition of Mars. So that's the closest point that Mars will get to Earth, and that happens about once every 2 years. Now, if you go outside, even around 9, 10 o'clock at night, that really bright red star that's shining in the sort of to the south, that is Mars. And now from this point on, it's just going to get dimmer. But, you know, we're still going to get really nice views for the next couple of weeks and even months, so that'll be good. Jupiter's still up right now for us on the west coast and probably even people on the east coast right now. Venus has gone down for the people on the east coast, but we're seeing it on the west coast. But people on the east coast will be seeing Saturn coming up within the next probably hour. It rises after midnight, I guess, on the east coast. So it is absolute astronomy heaven right now, and the moon is up. So in fact, you can see all 5 of the planets, of the visible sort of planets, within a few hours of each other. You can see Mercury and Venus just before they set. You can see Jupiter right after that. Mars is high. Saturn comes up after midnight. The moon is up. It is great. So if you have a telescope and you dust it off, highly recommend get out there and take a look. So, so the unfortunate part is, I think we've mentioned this in previous shows, Gary's setup is really well equipped for looking at the deep sky stuff. So we're going to see some really beautiful nebulae and some galaxies, and that's unfortunately all we can see. So we'll show you nebulae with greater detail live than I think you've probably ever seen, but Gary's setup is not really good for the planetary stuff, so unfortunately, unless one of the other astronomers checks in, we're not going to be able to view the moon or any of the planets, which is too bad, but this is astronomy. We take what we get. So, so Gary, so why don't you, so let's start. So you're looking at the Horsehead Nebula. You've actually got it zoomed in now, don't you?
Yeah, what I did is, last time we talked about binning, and this is what I do to get more light. This is taken at the full resolution of the camera. So this is, you're seeing pixel for pixel, the way the camera saw it. If I bin it, it's taking 4, I usually go 4 across and 4 down. So it's taking 4 pixels of the camera and making 1 out of it. So the picture's a quarter of the width and a quarter of the height. But I just wanted to go and do a zoom. So this is at 100% right now. So this is what my camera is seeing on the pixels. And I don't know if you probably can't see the noise bits in there. That's going to get smoothed out. So let me, we've seen that. Let me see what I can get over here.
Now, did you have an agenda again? Some of the neat stuff that we saw last time?
A few things. Not a lot, but a few things.
I'm wondering if we want to start with Andromeda, because is it still up for you? Because last time Andromeda was starting to sink down pretty quickly.
Yeah, that's probably a good idea. Let me send it over that way.
So if this works, we'll take a look at the Andromeda Nebula, which is the largest, I guess the closest major galaxy, the Andromeda Galaxy. Man, my brain is fried tonight. Okay, we're going to look at I should focus on what we're talking about. We're going to look at the Andromeda Galaxy, aka M31, which is the closest large galaxy to us. It's located 2.5 million light years away. You could tell me if I'm wrong. Is that right? And it's huge in the sky. I mean, you can see the Andromeda Galaxy with the unaided eye. You don't need a telescope to see it. You can just see this gigantic fuzzy patch in the right part of the sky. If you've got fairly dark sky.
Okay, gigantic is an overstatement. It looks like a star that got blurred out, like your eye doctor put the wrong lens in.
Yeah, but
it's,
it's like
it's
the
the
size
only,
of the moon.
not with what you can see with your eye.
Here, sure, in dark skies, you see this big fuzzy bit over in the direction of, the Andromeda constellation. Yeah, maybe not like the size of the moon. I see what you're saying. But you know what's really neat? I used to do when I used to do some observing when I was even a teenager. What I would do is I would go outside with we had really dark skies where I grew up, and we would look up, and I would just look in the sky for fuzzy bits with with my own eyes, and then I would follow up with binoculars and kind of go, yup, still fuzzy, and then I would follow up with a telescope, and then I would figure out what it was that I was looking at.
That's cool.
I discovered all kinds of things, right?
I've gotten lost in the direction of Sagittarius that way.
Yeah, there's all kinds of
Sounds
things.
a bit like the big cluster of galaxies during the Messier Marathon. A lot of times I'll be trying to figure out what galaxy am I looking at right now. There's like 20 of them right here.
Yeah, that's what slows you down doing the Messier Marathon is there's so many things in certain patches of the sky that it suddenly becomes I know I've got one of them, but which?
Well, that doesn't really slow you down too much because there's like a 2-hour gap right there where nothing's coming up for a while.
Yeah.
Yeah, one of my goals is to try and do a sort of simultaneous Messier Marathon. So I'm hoping with some of the folks that we have in England and Turkey and the West Coast and the East Coast that we could wrap up a Messier Marathon in 2 hours.
That would be a little bit wild.
Cheater.
Yeah.
Many hands make light work. So the Messier, for anyone who wonders, the Messier objects are these comet-like blurry bits that were identified by Messier a few hundred years ago because he was trying to find comets. And so what he did, he kept noticing these spots and to make sure he was looking at something new. So he cataloged all of these blurry objects, and so now it's sort of a challenge. Can you find all 110 Messier objects?
Yeah, 110.
Of a single evening.
Yeah.
And this is the challenge. So, yeah. Some are easy, some are hard, and the problem is they rise at different times, right?
Yeah.
So this is good. So I think, okay, so we can see now, you can see that bright central core on Andromeda, and you can see the dust lanes of the galaxy, and you can even see star clusters in the dust lanes if you can look really carefully. I'm not sure.
And you can get 2 of the neighboring galaxies to the above right and to the bottom left.
Yeah, which are those?
It's
110 and 32?
33, I
33.
think.
32, 33 is the pinwheel, isn't it?
I should know.
Triangulum is M33.
This is a 1-minute exposure. While we're looking at that, I'll go ahead and fire off a 2-minute. We'll see a little bit more detail in there.
Yeah, one of the problems I'm running into is there's this fabulous piece of software called Stellarium, which I know Fraser's been using. And whenever I turn it on, it takes over one of my 2 monitors in a way that makes the Hangout not work successfully. So I need to get paper solutions. And I have it on order, and Sky and Telescope told me it shipped today. So hopefully it will become more articulate once my paper solution arrives.
So what are you going to do? You mean Stellarium because it like pops the...
Yeah. I haven't succeeded in figuring out how to do that, which is user error.
Out for my
I fully admit
Windows
that.
version.
Let's see if it works. Let me try Stellarium here.
I haven't used Stellarium in a long time. I now use, on my Mac, I use Starry Night Pro. On Windows, I use the SkyX. And on my iPad, I use 4 or 5 other different ones.
Yeah, the iPad's awesome that way.
Is this working? Can people see this?
Yeah.
Yeah, I see it.
Yes, we can.
Yeah, so this is Stellarium, and literally run, don't walk, install Stellarium on your computer. It is free. It works on Linux, Mac, PC, and it's amazing. So what we're looking at here is we're looking at the night sky from my perspective here on Vancouver Island. So you can see if I look to the south, there's Sirius. There's Orion a little higher than that with Betelgeuse.
Go look up what's on either side of Andromeda.
All right, so I think where my Andromeda is. There's the moon from my perspective. There's Leo right there. And there's where Mars is in Leo. So Mars is actually up now for me. And I think where I'm going to find Andromeda. Hold on a second. I'm going to find it here. That one?
Ooh.
And then you can turn on all the different deep sky objects.
So can Gary. He just does it in a very different way.
And there's Pleiades.
Yeah, I cheat.
And so you can see from my perspective here, Jupiter and Venus haven't set yet.
Right.
So there is the Great Nebula in Andromeda. There's so much stuff. And you can zoom in, although I don't have my mouse on right now, so I actually can't zoom in. Maybe I can zoom in and see if that works. No. So you got to use a mouse and a scroll wheel on the mouse, or the hotkey, whatever it is. So that's what we're looking at right now. So if you want to go outside, right, if you can find Venus and Jupiter, you just want to look further past them and you can see Andromeda. Looks just great. So again, this is Stellarium, and Stellarium is cool. Like, watch this, right? So you want to see, watch this. So here's Jupiter and Venus, right? So what I'm going to do is I'm going to focus it on Jupiter. And we're going to fast forward. There we go. So we're on Jupiter right now, and I'm going to fast forward to March 13th. Now watch what happens. Whoa, whoa, whoa. So this is the 8th. See what they're doing? I don't know if people can see this now.
Turn the ground and the sun off, and it'll be a lot easier to see, I think.
Yeah, but then you lose track of when things are actually up, and I've almost had a bad telescope moment doing that.
Okay, so this is the 13th. Let's just wait till this runs. There. So that's what we're going to see on the 13th, which is Venus and Jupiter right side by side in the sky, which is pretty rare.
And I see another camera challenge in our future.
Yes, yeah, absolutely. We will both challenge each other to take images of the conjunction. So that's the 13th. There's the 14th. Whoa. And there's the 15th. And that's when it's sort of... So for the 13th, 14th, 15th, you're going to have these two objects just really close together. So it's going to be really exciting. So we challenge all of you to get some close-up pictures of the... Challenge all of you to get some nice close-up pictures of Venus and Jupiter in the sky. Really neat. So how is your 2-minute exposure coming along?
It's on there. I don't know if this is showing up, but I've captured one of the things called an airplane.
That's awesome.
Can you see it on there? Just got a line
you
going through.
Airplane and not a satellite?
It's too well. You know, it could be a satellite.
Okay.
Airplanes
Yeah,
are
that's
usually
a
little
satellite.
brighter.
That's way too faint to be a plane.
Yeah. I was
Aren't planes
taking.
supposed to be more blinky too?
Yeah.
Yeah, no, it's satellite. I forgot it was a 2-minute exposure. I was taking 10-second exposures the other night, and I got a trio of satellites that were flying in formation in there about a tenth, about a fifth the height of the image, and they just moved down in each one.
That's awesome.
Kind of a neat shot. Okay.
So you can see those more star clusters up at the top of the galaxy too.
Up
Yeah.
in here.
Yeah, and so some down in the bottom corner and some in the top corner, and you can really start to see the nature of that other satellite galaxy there below it. And it's actually it is a satellite galaxy of Andromeda, right, Pamela? Like it's in a gravitational connection to Andromeda. Yeah. So sort of on the scale of the Large Magellanic Cloud, sort of?
They're bigger than the Large and Small Magellanic Clouds, but it's basically the same concept, and there's the possibility that having these there is part of what gives Andromeda its well-defined arms. but we can't see Andromeda face on, so we're not sure if it's more M51-ish or more Sunflower Galaxy-ish.
Here's a question for you, Pamela. Can a galaxy orbit another galaxy?
Totally, all the time. We actually
So
are
it's like
in a very...
in- Like
So
this, is it locked in orbit?
well, it's a multi-body system, so the orbits are evolving over time, and there's drag on the system because of all the gas and everything else, and this means that the orbits are decaying. So it's not the perfect Mercury going around the Sun, and two orbits look almost identical. But if you look at Mercury's orbit over 10,000 years, you see its orbit kind of goes all over the place. With these, it's even more so, where eventually things often get eaten due to the orbits decaying. So yes, it's going around and around, but it's more like it's going around and in and dying. It's a suicidal spiral.
It's a suicide mission.
Should probably mention that Mercury's orbit is funny because of relativistic effects, whereas the galaxy orbit's changing is due to tidal friction.
Well, and even different from the relativistic effects, all of the planets, because it's a multi-object solar system, all of the orbits over time, there's normal precession, but there's also multi-body problems that end up slightly changing the shapes and ellipticities over time. So Mercury is a special case, but all of the planetary orbits are evolving over time.
And feel free, anybody...
Okay, and I just...
This is live and interactive. Anybody's watching, feel free to ask us any questions in the comments. So on the post that contains the Google Plus live feed, there's going to be a bunch of comments. And while I'm looking at it right now, I see about 30 comments there. So if you have any questions about anything related to what we're looking at, or if you have any requests, you know, we take requests.
Yeah.
And,
otherwise, we just have way too much fun talking to each other.
Yeah, and,
right.
And we follow my whims. So, you know, feel free to throw in some of your requests. Now, good news.
One thing I wanted to show here real quick is Andromeda is low on my horizon. Right here, you're looking at the back of my scope, and it's maybe 25 degrees. So you can see the scope's pointed way towards the ground. I just wanted to show that this is not a good time of year for me for Andromeda.
Okay. It gets better.
Yes, it does. Now I'll move off to something else.
Is it getting better? Is it getting better only? I mean, it's more of a spring constellation, isn't it?
It's going to go down here soon and not start coming back up until around June.
The best time to look at it is in the fall when it's almost straight overhead.
Yeah, around October.
Yeah, it's a great time to go camping, especially if you have a college club.
No, I mean, what have we got coming up now? We've got, like, Leo is coming up now. We've got some of the spring constellations. So, okay, well, so where should we go now? What have you got planned for us, Gary?
Something a little bit of a surprise, and that came out kind of nice. Let me, that's centered enough, so let me do a nice exposure on the Bubble Nebula. And that's always been
cute one.
One of my favorites. Okay, now we get a full picture of it. I just set it. This targeting is when I go into focus and align mode, so I can set the scope up and put things near the center. So now I'm going into a full shot, and that was a 10-second. The bubble's right down here. You can see it with everything else around it. And that's 10 seconds, so I'm doing a 60-second exposure now. But this is live, folks, about as live as you're going to see it.
So this object is also known as Caldwell 11 or Sharpless 162. I'm learning about all these new catalogs as Gary goes and finds awesome things. And this is an emission nebula, and I'm looking at a fabulous picture of it that's in color, and if you could see it in color, it's this bright, beautiful red nebula.
What was the number again? I'll try and share it. What was it again?
It's Sharpless 162 or Caldwell 11. It's an ionized hydrogen region. This means that you take your normal hydrogen atom with one happy electron and you remove it. So really, it's a cloud of protons. But periodically, as the protons grab a electron back on, that electron that's rejoining the atom cascades off photons, and the color red from H alpha is the prominent color that you end up seeing as a result of this. So the bubble is actually created from a massive stellar wind that's coming from the bright star that's in the center of this little bubble. So this is actually an optimal object for Gary to observe because he observes through H alpha filters to block out most of the light pollution that comes from the LA basin.
Also NGC 7635.
Yes.
Oh.
And this is, this is an M something right up here.
That is M52.
Okay.
That's an open cluster of stars.
Okay,
I like
so
this one
that's
'cause it's almost when you stack a bunch of these hydrogen alpha, it's almost like glass. I mean, it really looks like a three-dimensional bubble.
Yeah.
That's the Hubble version. There's Gary's version, but you can really see that bubble, yeah.
What I love is in Gary's version, it looks like a yin-yang symbol.
Yeah, it does. Even a little dot in it.
Yeah.
okay. What else we got? Not seeing any requests here so far.
Flipping back over and looking.
I'm trying to remember, what was the one that we saw last? There was one that was quite surprising. It was the Thor's helmet, which was great.
Yeah, the Cone Nebula also.
Yeah, the Cone Nebula was really nice. Why don't we take a look at that? Now,
Okay.
I'm going to do one last look of the bubble, just you can just kind of compare. So this is a sort of processed astro image of the Bubble Nebula, and you can really see that bright star in the middle there, and you can see that other bright star over on the right. So then we can kind of orient. So let's take a look at Gary's picture here. So there's that bright star. In his case, it's sort of down and to the right, and you can see that bubble right in the middle there. It really does look like a yin-yang, doesn't it?
Yeah.
Yeah, and you can see where the yin-yang is in that one. So, fantastic. Look at that, and that cluster. Did you find out what that cluster was up in the upper left?
That's M52. That's an open cluster. And what I love about this bubble is you can actually really envision how this ends up happening. You have this fairly constant media. So imagine being in the middle of the fog. And this hot star just clears this bubble out, and all of the material that had been inside where there's now that bubble gets pushed out and forms the rim of the bubble. So imagine being in that fog with fans and spinning around and pushing the fog away from you and creating a hollow place inside the fog.
Okay, that one's low too, but I'll run the scope over there.
And those of you on Twitter, we're following that as well, so you can add questions there.
Oh, no, that's not fairly low. That's way up. That's perfect shot.
That's awesome. So the reason that you want to observe things when they're close to straight overhead is because of the amount of the atmosphere that you have to look through. The atmosphere all the way around the planet is constant width. But when you look straight overhead, you only have to look through the amount of the atmosphere that's straight overhead. Now, when you look off to the side, you have to look along the horizon and then through this long tangent going diagonal through the atmosphere. So you end up looking through a whole lot more air than you do when you look straight overhead. And that air is, if you listen to the Raleigh scattering episode of Astronomy Cast, that air starts to remove color, it blurs the image, does all sorts of bad things. So minimize atmosphere, look straight up.
So Ryan Meter just asked on the post. I'm not sure you're viewing. I don't know if you have a telescope to stream. Please let me know, and we can definitely bring you in. So if you've got a telescope view streaming right now, then let me know. But right now we want to save space for the people with the telescopes to jump in. One person mentioned that he's probably going to try and jump in. He's got clear skies and he's just setting up. So hopefully that'll happen.
So we're getting requests for Leo's triplet, if that's up.
Should be up for sure.
It's
So
up,
are we-
but I
About
think
26,
the
about
angular
26
size
degrees.
is
It's
gonna be
just
big.
coming up.
Were we
Okay.
done with the Cone Nebula? Yeah.
No, not yet. I'm centering it.
There it is. I see it.
Oh, there it is off to the right.
Yeah.
Oh,
Mhm.
tracking.
Yes. I'm moving the scope.
This is live, real
Nebula.
time.
And the fingers never leave the hand.
That's the way you do it. And if the fingers left your hand, I'd be really disturbed and slightly grossed out. More than slightly grossed out, actually.
Okay, that's going to be a good one. Let me get a decent exposure here. I'll do a 10 seconds so we can get that garbage off the screen, and then I'll do a longer one.
You can actually see where the teeth in your gears are. So the reason he's getting bright, streak, faint, 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 bright, streak, faint, faint, is you can actually see it sort of stop as it moves across the sky.
Yeah, it's also because I'm doing it over the computer, so I don't want to hold it down. I tap it.
Okay,
Even
so
though
that's
I've
what's
had it
going on.
miss the command because I'm remote controlling the computer that's out in the dome, and here I've had it say, oh, gee, I'm going to keep going. All right, let me do a nice 1 minute here. And here you can see the cone at this point.
I will screen share a fabulous picture of it to give people perspective.
That's
so,
cheating.
so, well, I'm just perspective. That's all. So you can sort of see also the size compared to Gary's view. So this is, you can see that really bright star that's right above the cone itself, and so you can see it over on the right-hand side of this image. You can see that really bright star that I was talking about. Oh no, John, you were wondering about the Rosette Nebula. It's fantastic. It's the best one of the bunch, in my opinion. It looks just phenomenal. So.
Yeah, the full angular size of that is larger than the full moon, and I know Gary here's got a telescope that likes to zoom in.
Yeah.
Or no, he's the other way around.
He's the other way around. He zooms out. So no, he can do the whole. He can do the
Oh
whole.
yeah. Then
Yeah.
let's definitely look at Rosette some here,
Yeah.
which is nearby this object.
Yeah, we'll go to the Rosette Nebula next. Then that'd be great. So what? So sorry. Did you explain what we're looking at, Pamela?
What was that?
What is this?
This
What is
is
this thing that we're seeing?
this is another region that's illuminated red from all of the hydrogen that's in the region. And you see an area that I believe is dark material again that has a star emerging from the tip, but I need to double check that real fast.
Wow. Well, you can see a lot more of the nebulosity on it. Now, when you see this, most of the images that Gary takes, you're going to see that it's brighter in the middle and then blacker around the edges, and that's not because he centered on some great big nebula. That's in sort of a it's because his mirror is circular, right? And you get different.
Well, it's the sensor in the camera that it can't illuminate evenly. Technically, it's called vignetting, and pretty much every camera has it. But if you're taking outside shots, you'll never see it. I mean, I've squeezed the center section of this a whole lot to get this, and what I do is I record that as a flat picture. I'll lay a white sheet over the scope and take a bunch of shots and then merge them together and then subtract it. So when I actually process, I take the opposite of this circle and subtract it from the picture, and it produces what's called a flat image.
Right. So
Right now we're just looking.
Mike Barrett has just joined us. Can you hear us, Mike?
Mark, yeah.
So Mark, you can hear us okay?
Yep.
Yep. So there is, I don't know, what is this? What are you showing us here?
Do I really have to tell you?
It's Titan. It's Titan.
It's a giant asteroid going to crash into us.
Yeah. Yeah, that's phenomenal. So what's your setup, Mark?
I just have a small Meade 90 millimeter refractor, and I just have my Canon DSLR plugged into the back of it. So you'll notice it jumping around a bit. That's me guiding by hand, because the mount that comes with it is pretty basic.
You're doing really well for driving by hand.
Yeah, that's phenomenal. Although have you got have you got like a Barlow or anything you can put on top of it, or can you zoom it?
I can do that.
Yeah, can you move over to that sort of nice sort of shadowed crater over on the left of the moon? There we go.
So what we're seeing here is the lava flows, the mare, that's all over our side of the moon. If you go to the other side of the moon, the one that's not facing the Earth, you don't see that. And then all around it, the white part is what's called regolith. It's just pulverized lunar rock that has been completely broken into basically a glassy talcum powder from the constant bombardment of micrometeorites.
And I think what's really important to really know here is that Mark's telescope is a 90 millimeter refractor. That's not a very expensive telescope. Like, what does one of those run?
I think it was about $400 or $500.
Yeah.
So it's not hugely expensive.
And then you've got your DSLR. So you're using like a Canon Rebel.
Yeah, it's a T3i. Yeah.
Yeah.
It's the same camera that Fraser and I have.
Yeah, we have that exact same camera. So now you just got it mounted right onto the telescope with like a T adapter?
Yeah, there's a port on the back of it that you just screw a T adapter onto, and it fits onto the lens area of your camera.
And so it replaces the actual lens, and so it just attaches the DSLR body to the end of the telescope.
Right, you're basically using the telescope as your lens.
Yeah. Yeah, so imagine you've now put a great big telescope as your lens. Yeah, that's a perfect way to describe it. So, I think it's really important for people to understand. I mean, look at this beautiful view. Look at these craters. I mean, you don't have to spend big money to get into this hobby in the first place. Yeah, we've talked about Gary's setup, and it's $20,000, but for less than $1,000, you can have a really nice refractor or reflector and see some really visual astronomy. And even, I'm sure you can do, Mark, you can do some nice views of the moon with with video. You're not going to be able to do any long exposure astrophotography without a nice computerized mount. But
no, yeah, the next thing I'm getting is an equatorial mount as soon as the wife lets me.
Yeah,
that works.
That's phenomenal. Just wonderful. Could you where are you located? Do you still have Jupiter in the sky where you are?
I'm right outside of Chicago, and I think Jupiter is too close to the other side of my house right now.
How's Mars for you?
Mars is up, but it just kind of looks like a little red disk. I can try and slew over to it, but my alignment wasn't very good tonight because it was cold outside.
Yeah, I would love to just see, because I mean we're at opposition. It'd be really nice to just see Mars and deliver it. I mean, Mike, I hope, is watching, or if not, he had just a phenomenal view of Mars last week. So
yeah, let me see if I can get over to it.
Sure, that would be great, and then we can go back and spend the rest of the evening on the moon. But if we could just try and see Mars, that would be great. So Gary, here is my favorite, the Rosette Nebula, which actually is a great big spherical nebula. So we've been saying that don't ignore when you see this big sphere in the middle of the view, but boy, that nebula really looks like that.
Yeah.
Let me find a Rosette Nebula shot so you can kind of compare and contrast.
And the dark veins through it, those are again places where the material is much, much thicker, and it's blocking the light from the background nebula, which is, if we could see this in color, a whole variety of different colors in this case. Primarily red. Everything in space is primarily red. That's just the way the universe does things.
Well, and isn't it in many cases just the way people colorize them after the fact?
No, it's just a lot of H-alpha, and H-alpha is honest-to-God red. See, it's that color of the neon open sign, which is actually filled with hydrogen.
I see a request for NGC 4945, but I'm not showing that it's up for me.
So let me just give you a comparison. So this is a there. Okay, so that's a view of the Rosette Nebula, you know, captured with a long exposure. But this is the kind of picture that Gary can do with his setup. I mean, he could produce an image just like this.
Yeah.
So this is phenomenal. And so you can see, you can compare and contrast. You see those worms in the nebula there. I believe that's the technical term, right?
Not quite.
You can see them there. So his view is just a little bit rotated. But I mean, just look at those faint like tendrils of nebulosity throughout the structure. What a phenomenal view you've got. I mean, this is just amazing. And so we actually, in previous nights, have actually in real time constructed some photos of these, because the way a lot of astrophotographers work is they will gather the image in a series of filters. So they'll take it in the hydrogen filter, and then they'll switch the filter and take one in the sulfur filter, and then they'll switch and take it in the oxygen filter, and then you just define each of those to be different colors. So you make hydrogen red, you make sulfur blue, and you make oxygen green, and then you can produce an image that is a color image, and that's what we're seeing with like this object here. Is although it's very red, there's actually different colors in there all at the same time.
And one of the interesting things about this is the nebulosity part of it is Caldwell 49, Rosette Nebula. But if you look in the center upper left part of the hollow, there's a cluster of stars, and that's actually an open cluster, an area of stars that have finished forming. And they're the stars that are responsible for illuminating and ionizing this nebula. And that is its own object. That's Caldwell 50.
And I'm seeing a question from Neil, how wide is it? The view of my scope is 1 degree height and 1.5 degrees wide. So that's a big object.
Yeah, and the moon, in comparison, is about 1/2 degree, so that's about 3 full moon widths wide. It's just too faint to see with the naked eye.
And you can't see
your eye can gather light.
Naked eye?
I've never heard of anyone seeing it.
I'm sure there's some dude who's looked through a 4-meter telescope while lining optics, but
Leo triplet. Does that ring a bell? Somebody requested.
Okay,
that.
I see something in our
it's
hand-tracked
M66.
system. Is that Mars? Mark, did you get Mars?
I think so. That's about as good as a focus as I can get on it, and I'm at 5x, so.
I think the brightness is too much.
Yeah. Turn down your exposure time, or close your aperture slightly.
Also, looking up the Rosette Nebula, its apparent magnitude is about 9, and the absolute limit for people with good eyesight under dark conditions is about 7. Oh, hey,
got
it's
it. You
red
pulled
now.
it.
There.
Yeah.
There you go.
That's fantastic.
Make it a little bit brighter.
I would make
you're
it.
starting to bloat.
Yeah, I would go back where you were.
Right about there.
Yeah.
Yeah, even
a
a
little
darker.
contrast.
Yeah, you had good contrast even just before when you first set it. I could see some of the
Ooh,
some
for
of the
half a
darker
second I saw an ice cap.
Yeah. And this is where you find out who in the hangout needs glasses.
So now, can you digitally zoom that any bigger?
This is already 5x.
But with your software, can you zoom in on that part of your screen at all?
Let me see.
I think it's
Except you
dancing
can't
a little
track
too
and
much.
do that at the same time. So you can actually see the dark variations on the surface of Mars. And what's amazing is due to its volcanism, due to its ice caps, due to the constant blowing of the sands, due to the valleys, it's this amazingly varied in color system that's quite fabulous.
No, that's fantastic. No, this is as good a view of Mars as I think we could have hoped to see. I'm really pleased.
And this is a telescope with a lens, 90 millimeters. It's like this big.
Yeah. Yeah. So just keep in mind, if you're in the market for a telescope, even for a few $100s, you can get a pretty nice view of the sky.
Yeah.
And that's all we saw with the moon before. I just wish we could get Saturn. Oh. Because Saturn's not going to be up for another couple of hours, but if we had somebody
Patience.
East
Give it a
Coast,
couple
I know
of
it'll be up, in spring. I know I'm totally
Yeah.
yeah. It'll be up a lot better. Oh, that's fantastic. Nice work. Oh, I'm really pleased.
That's amazing for just a quick cobble together,
Yeah.
running out and taking pictures. Phenomenal.
Yeah, I'm starting to sort of mull over my perfect setup. I think how many people I've seen getting really nice views from their DSLR as their camera attached to their telescope the way you're doing it with the T adapter. It's a really nice way. I'm really pleased. That's the way to go. So question for you though. Normally when you're running it through your Canon, you're getting that white screen, that little white box on the screen. How are you not getting that?
I'm using a piece of software called Backyard EOS. It's a very nice piece of software. It gives me, a whole lot of controls over, what I can do. I can put the little white box in and out if I need to. I can, digitally zoom. I can. There's even a red mode for when you're out in the field at night.
Do you know?
Right now
know what
I'm
operating
taking it.
systems?
It's Windows. I know for sure. I don't know if it's Mac or Linux.
Okay.
I can post a link to it in the chat.
That's fantastic. Okay, well that's great. I don't want to sort of push your tracking skills to the limit, but I think that's awesome. And if you can see Jupiter, because it should still be up for you for another probably couple of hours.
It is, but it's pretty far east, and my house is in the way.
Well, move the house.
Yeah, move the house. Move out on the street somewhere. Yeah. We had that one time. We had one person joining us, and he started on one side of his house, and then he moved over to the other side of the house, and got a view of something else. So
Yeah.
So what have you got going on, Gary? Do you want to go back to the moon then, Mark, and we kind of stay there for the rest of the night?
Yeah, sure. I can move back over.
That'd be great. Thanks.
Sure.
And so, Gary, what have you got here?
This is one of our favorites, Thor's helmet, and that's a 10-second, just so I could see that it was lined up, and I'm halfway through a 2-minute exposure, so we'll see a little more detail. I love things in space that are bubbles.
Yeah, and this is one of those nebula that looks exactly like its name, so you can actually see the horns on either side of the helmet.
And what's amazing is this what looks like a little bubble is 30 light years across. So light from one side of that takes most of my lifetime to reach the other side. Sadly, not all of it. Sadly, I'm older than. Yeah, I'm going to stop there.
And light.
Wonder how far you were going to take yourself there.
But there's a hot central star in that called a Wolf-Rayet star, and it's the type of star that will eventually explode quite nicely. But in the interim, it has really hot winds, and those winds are creating this little bubble.
So, refresh my memory here. I know there's been so much debate recently. Well, I shouldn't say too recently, but when I was going through school 5-10 years ago, is Wolf-Rayet stars a really young star or a really old star?
They're really young, but the
really
thing is, they die young as well. So you have these stars that only live, I think, order of 50 to 80 million years, and so they spend the most of their lifetime being Wolf-Rayet stars, happily burning hydrogen and other stuff because they're so hot in their core. And when they evolve off the main sequence, they very, very, very quickly finish off their life and explode.
So these are massive O-type stars.
Yes.
Beautiful.
There we go.
Yeah, you can really see the vignetting. I wonder if there's any way to remove the vignetting in real time.
You can, but
I actually had some
Because of the
set up.
software.
you just need to flat field everything, but that means taking your flats before you get started.
I think I have some out here. Let me look real
Okay.
quick.
When I was in graduate school, I used to take one of the undergrads who was smartest guy I've known in a long time as a student. And he would operate the telescope and I'd reduce the data, and it was nice because by the time we're on our second image, we have the first image fully processed.
What you're looking at right now is, where am I saving these? That's a flat field. Hang on, I'm saving these pictures on my other computer. I love when you come up with things that I can't do right off the top. It's going to be...
It's very rare. There aren't very many
here. Yeah, there's a lot.
The flat field itself tells you a lot about your optics as well. If you look at the corners of it, you can see that your CCD chip is not directly in the center of your mirror either.
Yeah.
Yours is better than mine, though.
Well, what's really nice is you have no obvious defects.
Yeah.
The telescopes I've used have always had a dust ring here, a scratch there, and you have none of that.
There it is.
Beautiful.
There is...
There's a little bit of it's a little bit unaligned, but so what you had before, Gary, well, like one step back down, it was perfect.
Back here?
It was a little darker. No, the other way. That. Perfect. Look at that. That is
We got
phenomenal.
a little bit more of it.
I love how this and the Bubble Nebula are basically the same phenomena, and we end up with different shapes just because of the way gases align and way disks form around stars, and so many other small variables just give us this amazing diversity of pretty things. It also keeps people busy trying to model it.
Yeah. Well, I need a secretary here to read the post what people want to look at.
Well, that's true.
Yeah.
2841. I'm not
requested-
ignoring anybody out there.
The Leo triplet is M66, so that would be a quick one to look up. I was also wanting to see the Heart and Soul Nebula
Okay.
since you have a good wide field.
Oh yeah. Okay. Let me slew over to 2841 because that's on the way.
Yeah, that's up pretty high.
Mm-hmm.
What's 2841?
It's a pretty galaxy.
It's a spiral galaxy.
When I was in graduate school, one of my advisors, John Cormody, was someone you could walk up to and you could go NGC 5582 and he'd bang know exactly what it was. And I really wish I had that skill, and I don't.
You have a tremendous amount knocking around in your head, Pamela. I would not worry. Look at that view of the moon. Oh, that's just beautiful.
Yeah, that really, really is. You have it beautifully framed as well.
You must have taken some really nice pictures of the moon. Have you got some photos somewhere people can see, Mark?
Yeah, I put a whole bunch of them on my Google Plus whenever I get a decent one.
Cool.
Very cool. I will reshare them. I should actually share my virtual star party circle so people can specifically include them. That's great. But I really want to see, I mean, that whole moon is great, but I really want to see that stuff down on the bottom left-hand corner.
Okay.
Yeah, so I don't know, just to see where you can see all that cratering. The moon is getting really full, though, isn't it? Wow.
Oop, too
Yeah.
far.
It's amazing how quickly it changes position, changes rise and set time and phase. People, I don't think, realize just how quickly the moon wanes and waxes.
Did you see that
Uh-oh, I
recent
lost
video
it.
that Phil posted? He posted this amazing
No.
video just about just a couple of days ago, I think, that had the moon running through every phase through all of 2012.
Oh, wow.
And I think we posted a link to it on our Twitter. It should be within the last 10 tweets. I'm trying to remember what it was. But what's really interesting is you really see both how the moon is coming towards us and away from us, right?
Yeah.
So you see, because the moon is on this elliptical orbit, and so that, you know, sometimes the moon is closer and sometimes the moon is further, and so sometimes the moon is bigger and sometimes the moon is smaller. And so you can really see this oscillation as the moon gets closer and further away. But the other thing that's really neat is how you can see the moon. It looks like the moon is kind of doing this, right?
Yeah.
I guess it's a perspective thing, how we're seeing the moon as it's going around us, and so we're seeing like a peak of different views of it. Anyway, it's a phenomenal video. I will try and post it into the chat, and people can watch it. It's really neat.
Yeah, there's been a number of videos like that done over the years. And one of the things that I'd love to do is someday get a fisheye lens and do with a camera what I used to always assign my students to do as their homework, and basically set up the camera to every night take a picture at the exact same time to show how the sky is evolving from night to night with photos instead of with Stellarium.
Oh, there we go. Look at that.
Yeah.
So people don't realize, but when you see the moon, I mean, a lot of the times when there's a big, bright, full moon, people think that's the best time to look at the moon.
Yeah.
But that's actually about the worst time to look at the moon, because the sun is hitting the moon pretty much face on, and all of the craters are just washed out. And so you can kind of see right now, you know, the moon is very bright and all of the craters are washed out. But what you really want is you want these quarter moons, and even like almost outside of new moons, where you can see where the whole moon is this shadowed part over on the left-hand side of the image. You can see where the terminator of the moon is, where the shadow, the light between the shadow and the darkness is. You can see the craters with the long shadows, and that's when you can see the relief. You can see how these craters really look.
Yeah.
And it's just now you're just showing off, Mark. This is awesome.
With moon mappers, we're actually looking to document what is the absolute optimal angle for the sun to be at in order for people and computers to both identify craters accurately. So if you go use CosmoQuest/moon mappers, you're going to find that in some of the images you have the sun in one place, some of them you have it in another place, sometimes the shadows are longer, sometimes they're shorter. And the reason we're giving you all of these different types of angles and images is to figure out what can we give you in the future that will give you the best chance of working accurately.
So geometry
let's see
problem.
what.
You
So
got
Gary,
the
what have you got
shadows.
there?
Did you figure out the height?
Yeah, sort of. Mostly the problem is sometimes things dip below the surface, and sometimes you have plateaus, and so it gets complicated. But yes, judging the height is one of the goals from the shadows. It's much easier to just use Lola. Lasers work really well.
So was this the request, Gary?
Yeah, this is NGC 2841. I don't see who requested it, but it's a fairly small galaxy, so when I'm set up right now, this isn't optimal for my setup.
How long's your exposure?
That's a 1 minute.
That's a 1 minute exposure, yeah. So it's just not as big. So you can remember when we saw Andromeda, how Andromeda filled up his whole field of view, and this one's a pretty tiny little one. There was another. I remember one of the early observing sessions we did. We got a view of a fairly nice face-on galaxy, but I don't remember which one it was.
M51, M101.
I don't think it was 101.
Might have been
51's
33.
Pinwheel, isn't it?
Whirlpool.
Whirlpool.
Pinwheel. Is 51 up right now?
Well, I'll take a quick shot over to M66 here.
It's probably going to be pretty low still.
Yeah.
Yeah, it's off, but it's off to the east, which is my darkest direction.
.51 would be about 16 degrees.
Mm.
So that's going to be too low.
Yeah, I'm trying to look through my notes. We might have looked at M33.
Okay.
Hard keeping track of these and keeping notes.
33
Yeah.
would be the Triangulum Galaxy at 29 degrees.
M33 is going to be too low on your horizon, the Triangulum.
Yeah.
Yeah, it's kind of right by Andromeda, and so it's pretty low down. Like, you might still be able to grab it, but I think it's going to be too low down for you. What was the other one? 51?
Yeah, M51's.
M51 is going to be just below the Big Dipper, right? Just below the handle of Big Dipper. Have you got a view of that?
Let's see. Let me get the triplet here.
I don't think you're going to. It sits down about 16 degrees.
Yeah, I'm seeing it. Well, I'm further north of you, so.
I'm just going from mine, and it's not going to be too much off from
Yeah,
Las Vegas to California.
Yeah.
If it's too low for me, it's definitely going to be too low for Gary.
Yeah.
Leo triplet should be okay. Pretty
yeah,
low.
I see 2 of the 3 in the triplet.
Yeah, I'm moving the
Yeah.
scope a little bit. I want to go down. Which side am I? That's also the other thing that's confusing, is up and down reverses when the scope's on the other side.
Yes, it does. That one's bit me a few times.
I've got all kinds of, on the shelf above me, I've got little crib notes. Say, this is up, this is down, when it's west, when it's east. I'm just doing a 10-second alignment shots. There's the third one coming in right now.
Sorry, so Peter Jensen said the moon wiggle looks a bit large to be just perspective. Is it really due to perspective? Sorry, so when you say wriggle, do you mean how it's moving, or do you mean...
What he's
So the
talking about
moon
was something you were talking about earlier.
appears to essentially be doing this, where it's
yeah.
changing in both size and how much of it we can see. And it's all caused by the ellipticity of the moon's orbit. So the moon actually goes from being closer to us, which is why we sometimes get annular eclipses, to being further away from us, which is why we sometimes get much longer full solar eclipses.
Mm-hmm.
And along the way, because it goes at different speeds depending on where it is in its orbit, it goes faster when it's closer and slower when it's further away, we end up sometimes getting to see a little bit more of it in either side as it zips ahead or back in its attempt to always keep one side facing us but having variable orbital rates.
Right, but you're also saying as well that the orbit of the moon is not on the same exact inclination as the Earth's orbit, right? And so the angles from the sun and the moon
Right.
and the Earth all kind of change depending on whether we're seeing it from a little bit down below us or a little bit up above us.
Yeah,
right?
so that gives us the north-south wiggle, and then the east-west comes from the rotational rates.
Yeah, phenomenal.
Yeah,
I
the
don't know
effect is known as lunation.
Yeah.
Lunation. I don't know if anybody saw Mike Brown has been sort of live Google Plusing his observation night on Hawaii. So Mike Brown was the leader of the team that discovered Eris, which was the sort of object that was bigger than Pluto, further out than Pluto. And so Mike is in Hawaii right now, and last night he was updating the discoveries that they were making with an asteroid. They were trying to check. They found an asteroid with a moon orbiting it, and they were trying to find out if the orbit of that moon is stable, I guess, or going inward or outward, as some people might suspect. So it was really neat. So if you want, do a search for Mike Brown, and circle him, because he is a source of really interesting information. We actually interviewed him on Google Plus just about a week ago. It was neat.
We need to get him and Alan Stern on at the same time.
I don't know. I'm scared. Yeah, I'd be afraid.
So the reason that we say that is Alan Stern is a firm believer that Pluto and Ceres and Sedna and many of these other objects are planets and should be called planets. And Michael Brown is going to go with what the IAU said, so he's going to fight to the death that Pluto isn't a planet since his 10th planet discovery got taken away.
If the 9th one's not, then the 10th one's not.
Exactly.
Yeah, and so he's known as the Pluto Killer.
Yeah, and he wrote a book to that.
Yeah. So Sarah Madero just mentioned that she's in the city of San Bernardino, which makes observing really rough. And Gary is actually in pretty close to that, right?
Rancho Cucamonga.
There you go. So there's your vignetting back. And so he knows he's got really bad light pollution, and so he's got his telescope set up to view in a very specific sort of type of frequency of light that is able to sort of pass through a lot of that light pollution. And so he's able to get a really nice view, even though he lives in really horribly light polluted skies, which is really great.
But that filter is really only going to work well when you have a CCD attached. If you're cutting out that much light, you're not going to actually get very good views just with your eye to the eyepiece. Yeah.
But I think anybody who's worried about their light polluted skies, you're going to see the moon, like Mark's in Chicago, and now he's getting clouded out. But
that's a different problem with being in Chicago.
Problem, yeah. But I mean, you're going to see about the same moon, no matter where you live, and the moon is so bright it just blasts right through any light pollution. You're going to see
Jupiter and Saturn are the same.
Jupiter and Saturn and Mars and Mercury, and you're going to see some of the brighter objects. I mean, you can see the Orion Nebula anywhere. You can see some, some of the nicer globular star clusters. You can see there's a lot of really great objects. But I mean, the real crowd pleaser, right? The Moon and Mars and Jupiter and Saturn. You can see those from even the most light polluted cities. So I wouldn't really worry. If you want to get into astronomy and you live in a light polluted city, it's still great to be able to view the planets. Just don't invest in a really great, in a Takahashi, really expensive telescope, and but get a nice little refractor. I think what Mark has is the absolute perfect telescope. I think for most people, he's got the exact right setup.
Or a Dobsonian. I'd argue for a Dobsonian.
Yeah, I've been happier seeing the views out of these refractors than the Dobsonians. But it's true. I mean, you can buy a 10-inch Dobsonian, which is just a light bucket, for almost the same price as a 90-millimeter refractor. So either way, I would say.
The way to decide between the two is you get better contrast with a refractor because you don't have the secondary mirror in the center. But with the reflector, for the same cost, you're able to see much fainter objects.
But if you're in a light polluted city, you can't really see that very many faint objects because the light pollution is
it still scales. The larger the mirror, the more you can see. So from the roof of Harvard in Boston, we were able to use our 6- and 10-inch Dobs to start getting at globular clusters and open clusters. So you're not going to really be seeing galaxies, but you can start to get down to being able to make out clusters without any problem. And if you're really good and you're careful with your focus and everything else, you can start to get at some of the brighter galaxies.
So there's the Leo triplet. Are they interacting gravitationally, Pamela?
Yeah. I don't think all of them are, but let me double check this. I remember looking this up before and being surprised at the answer.
They are alien spacecraft.
But I screw up this one and the Stevens sextet in terms of how they're interacting.
So Sarah mentioned that she's got 15 by 70 binoculars to work with. 15 by 70 binoculars are pretty sweet, actually.
Yeah.
Have a 1570. That's a pretty nice view. I really like looking through binoculars. I mean, seeing a nice view through a telescope is great, but there's something really great about using binoculars because when you use both eyes at the same time to view an object, you actually can get a much better view, see things a lot more clearly, and things take on this 3D view in the sky that you just don't get looking through a telescope. So, yeah, I think for most people out there, if you want to really get into this and take, beyond the unaided eye and take it to the next level, we always recommend binoculars. And I think what Sarah has, what she's mentioning, she's got 15 by 70. That's a really nice astronomical set of binoculars. Most people are going to have a 7 by 35 or an 8 by 35 or 8 by 40, so that's going to have double the magnification with the 15. Because we use binoculars, right? There's two numbers. There's the 8. There's the first number, like 7. That's the magnification, and then it says by, the X, and then 35. And 35 is the size in millimeter of the lens, of the primary lens. Yeah. And so bigger lenses is bigger, is more light capacity, and so. In Sarah's case, she's got a 15 by 70, so she's got a 15 magnification. So the moon is going to look 15 times closer than it does in the sky, but with a 70 millimeter lens that's gathering light and bringing it into you. So that's a pretty nice setup, actually. I'd like a pair of those. That's great, fantastic. Well, we're starting to. I think we've been at it for about an hour now, an hour and a quarter. Any last requests?
And while you're thinking
of it,
about the moon appearing horns up.
Right. So that's actually a matter of this part of the moon that's illuminated always follows the sun. So if you have, I need a set of Nerf balls on my desk, and I don't have a set of Nerf balls. If you have an EOS CD that's pretending to be the sun, and it's beginning to sink below your horizon, as it sinks, you have the moon rather following it, and I'm trying to, here, this will work. You have the moon following it. And as the moon follows it, the side that's illuminated always stays facing the sun. So as they move through the sky, you'll see this actually rotates, and then, so when it was rising over here, it rose horns down, and then, the sun rose first, so you have the sun coming up, moon following it, horns down, they move through the sky, and then it sets with the horns up. So that's how it works, is it just follows the sun through the sky. And this is how you figure out if you're looking at a picture from sunrise or sunset.
There was a...
down.
Recently when Neil deGrasse Tyson was on Jon Stewart, I went back and looked, and he had sort of mentioned the same thing about the moon on one of Conan O'Brien's shows a long time ago, and that's what he was complaining to him, that the moon he had on his set was wrong, because at the time of night, it shouldn't have looked like that.
Yeah, I remember that. Neil likes to be pragmatic about things like that. He actually got very upset that on the movie Titanic, they didn't have accurate star fields.
Yes. But
I think around Christmas...
On the re-release.
Wasn't there a poster around Christmas
Go ahead, John.
looking at Christmas cards, and a lot of the drawings of moons on Christmas cards were physically impossible?
Yes, that's true as well.
I was at a convention last month, and they had this beautiful picture up on the wall of a full moon during the daytime, which can't happen.
No. Crescent moon during the daytime. Half moon during the daytime. Well, you could have a full moon if you had geometric impossibility and you were in Antarctica or something, but then you wouldn't really be able to see it.
So hold on. So Mark, how are you doing this? Because I thought you were outside in the cold. You look like you're inside. What's going on?
I bought myself a 50-foot long USB cable.
So to return to the question we had earlier about is Leo's triplet gravitationally bound together? Yes, it is, and it's actually probably gravitationally bound to a nearby group of galaxies. But what's interesting is there's another group, Stefan's sextet, that they look like they're all deeply interacting, and they're not. There's a few of them that are interlopers in the foreground and the background.
It really is facial hair night here on
Yeah, so what those of you watching didn't see is I actually posted a comment earlier to John and Fraser asking if there was a Universe Today beard growing thing going on, and now we're seeing that this is pretty much across the board. Mark's joined in as well.
I just trimmed mine just like an hour ago too. It was literally like homeless man looking. So I got too many comments about looking homeless, so I had to.
Come on, Pamela, get on board.
I know. Sorry.
So what else we got?
Just move over to M81 and M82.
Oh, so Ryan Meter
That's a good shot.
The Cone Nebula, and it is physically impossible for the astronomers on hand to view the Cone Nebula. The problem is that it's too far to the south.
We desperately need some folks in South America and Australia to help us out. So right now, not so good for Australia, but we need some solar observers, so we still would love you. But there we're also good with Northern Hemisphere, so those of you in China, Indonesia, further north, also would appreciate your help. But if we could get some folks down in South America, it would really help us be able to extend this star party across both hemispheres. Ooh, pretty.
So which one is that? That's beautiful. That's phenomenal.
81 too.
Yeah, 81.
Yeah.
81's the face-on. 82 is the exploding cigar galaxy, as it's also known.
There's some definite weird stuff going on in there.
That's good, and you're removing the vignetting pretty nicely.
Yeah, M82 is one that's definitely something that's recently had a very nasty collision, and it's still working on settling out. So when you start looking at it across multiple wavelengths, you can see this weird pattern of splished material all around it.
You've got a weird chirping coming from your mic, Mark. I'm not sure what it is, but there's something kind of chirping.
Probably me just clicking around. Sorry, I'll keep myself muted.
Yeah, yeah. So you can really see, I mean, I don't know if people can see, I can really see that spiral nature of the one. That's M81 in the middle, right? And then M82 is the cigar. Yeah. Yeah, look at the spiral nature. You can absolutely see the spiral arms there.
Yeah.
That's nice. So M51 should be visible if it's still up. It's just a little off to the side. I mean, if you're getting M81 and M82, you could probably...
And to clarify, it was the reverse. M81 is the active cigar-shaped galaxy. M82 is the spiral.
Right. So if you're getting them, Gary, you probably should also be able to get M51.
Yeah. It's up enough. I'm going ahead and popping over there now.
No, I'm pretty sure I had it right. M81 is the spirally one.
Ooh, fight.
Fight.
Wikipedia
Okay.
agrees with me.
Astronomer fight.
See, I thought M81 was the active one. Dang it, APOD lied. Okay. Sorry for miscorrecting you. I was lied to by the caption of an image. The internet lies.
So Scott Lewis was mentioning on the comments that he picked up his 15 by 70 Celestron Skymaster with a tripod for about $100, and just got solar filters the other day, which I think would be phenomenal. So looking at the sun through binoculars would be outstanding.
I have solar filters for my binoculars, and they're awesome.
Yeah.
It's hard to find the sun, surprisingly, though.
In fact, Scott's mentioning now on Amazon, a pair of them are available for $62. Whew, that's tempting. I might just buy one right now. That's a nice binocular.
Hold up the image of what Pamela was talking about here with, if you look at this pair of galaxies in the right wavelengths, you can see this kind of bridge of stuff going between them.
Yeah.
This one is rotated differently, so M82 is the one up on the top, but you can see this big arc of gas that's been pulled off, and there's actually star clusters that are formed within those pulled out tails.
So this is M51, right, Gary?
Yeah.
Great.
Doing a longer exposure. Hang on.
I totally see it, though.
Yep.
I can totally see the whirlpool in it.
Got about, I'm 80% of the way through a 1 minute exposure. Of course, now I found out that they've come out with a new camera that downloads much, much faster, and I can upgrade my electronics, so I may have to spend some more money one of these days.
Don't do it on our behalf. Oh, wow!
I'll do it for me. I hate the download
That's
time.
adorable.
Oh, that is amazing.
But this really gives you a sense for just how big his field of view is.
Yeah. Let me see if I can get an M51 view.
This is a beautiful blue system with a friend off to the right that's slightly more beige in color. And the reason that the arms are so perfectly formed in this is because of the gravitational interactions between the two systems.
Okay, I'm going to screen share a Hubble-ish picture.
This is also the one that had a supernova back in July.
Yeah.
I got a picture of it with the nova going, with the supernova going.
Oh, really? So here's the sort of official view, and you can see that that sort of the one major galaxy and those beautiful spiral arms, then that sort of smear off on the left. And so if we take a look at Gary's view, I see the same thing. That's amazing. That's my favorite galaxy. That's the best. I mean, the Andromeda one is just so big and visible, but this one is just so clear. So can you vignette it? Oh yeah, there we go. Look at that. Wow, that's a phenomenal view.
Going one step farther, that's going to be too much.
So how many seconds was that?
That was 60 seconds.
Could we tuck you into a minute and a half or 2 minutes?
You absolutely can.
Well, you normally do, what, like a 5 minute?
Yeah, it depends on what I'm shooting, but I'll do 5. 10 minute is usually the most I do, because I'd rather add a bunch of 10 minutes together than do a 60 minute and have an airplane go through the middle. So with 10 minutes, I can always throw some away if they're ruined by something. But I've actually set a little goal for myself that I'm 3/4 of the way through. I'm taking a picture of every Messier object from home in hydrogen alpha. And I got another 8 of them last night.
Wow.
Oh.
So hopefully I'm going to get that finished. That's just decided I'd do it.
Are you ready for our Messier marathon? I think you'll be able to do most of them. I guess whatever will be visible from your, from your point of view.
He'll be able to do them faster.
Yeah. So the moment they're available on the sky, he'll be able to go right to them.
Yeah.
Yeah, but that's cheating, as some people would say.
Yeah.
What takes him a minute would take me a 6-minute shot.
Yeah. Yeah, look at that. So you're doing the 2 minute exposure now?
Yeah, 68% of the way through.
That is phenomenal. Yeah, I love the fact that we try stuff out thing, and then boom, it just looks phenomenal. Like, it just keeps surprising me how good.
Pam, I think we're getting some static from you.
I think it's you,
Oh,
Pamela.
sorry.
You have like a really bad, some kind of feedback coming from you, Matt.
Okay, 98%. And we've started downloading.
Pamela, there was a question on there while we were waiting for that, if your microphone is up to it, on galaxy shapes. Want to know how they're all classified?
So the most popular schema for classifying the shapes of galaxies comes from it's the Hubble tuning fork diagram. Hubble took so many images of so many different galaxies, and he started looking for patterns, and we didn't understand galaxy evolution at this point. And so there was this original thought, theory is probably too strong of a word, there was this original thought that they went from some sort of elliptical round blobbiness to pretty spiraliness. And so he did this diagram that goes from squished cigars with no discernible arms out to rounder and rounder, to then disk, which is the lenticular transitionary stage, to then having arms, and then the arms unwind as you go out to the different types of spirals. And some of the spirals have bars, and some of them have no bars. So this is strictly based on how they look. And it's led to some interesting terminology, because since it was thought that ellipticals came first and spirals came later, we call ellipticals early type galaxies, and they're not. And we call spirals late type galaxies, and that has no meaning whatsoever. But it's based on this original diagram. Other people came up with other systems, many of them much more complicated. De Vaucouleurs is the one that graduate students get tortured with. But the one that's most commonly used is the Hubble diagram.
Now you had, could still be running as well, is Galaxy Zoo?
Galaxy Zoo is still going on. That's a project put together by the Zooniverse that is looking at a variety of Hubble galaxies.
Is it finished your 2-minute exposure, Gary?
Yes. Yep, that's the 2-minute.
It just
didn't improve too much, though.
No.
No, at this point, the longer exposure and the stacking, I also pick up more noise. The stars that are real tiny in there are actually noise.
Okay.
But it picked up some. I can see a little more definition in the spiral arms. I can make out the arm between the two, which we really didn't have last time.
Yeah. So the noise that he's talking about is what's called cosmic rays, and these are high-energy particles that are either coming from the ground, from radioactive decaying granite, or coming from outer space, either from the sun, from distant supernova, from all sorts of different high-energy interactions in outer space.
And to add to that a little bit, the CCD chips are never perfect.
Right.
So they have not particularly defects.
Currents.
Yeah, I have dark pixels or light, hot pixels. So, but they tend to stay consistent. So you make some shots. If I do 10-minute exposures, I'll do a whole bunch of them with the shutter closed for 10 minutes and then average them out, and I've got an average of what that CCD is going to give me, and I can subtract that from the picture also.
And professional telescopes have the same problem, and the way that we deal with it with professional telescopes, including Hubble, is you actually move the telescope a few pixels between each exposure so that the same star, the same blob of gas, the same part of a galaxy doesn't fall on the same hot or cold pixel, because they come in both varieties. It doesn't fall on the same defect in your camera in every image. And so when you add the images together, you usually add it together so that if you have 10 images, you yank out the one that has the minimum value when you're putting them together, and you yank out the one with the hottest value, and you take the 8 that are in between, and this gives you a representative image that has hopefully gotten rid of all of the bad characteristics of your detector.
So your tracking has become very, very stable, Mark, which is leading me to believe that I think you've switched to a photograph or a video.
Yeah, that's a picture I took. The clouds rolled in pretty quickly and pretty drastically, and I was afraid it was going to start snowing again, so I ran out and grabbed all my stuff.
Yep. No, that's good. So was this from tonight?
No, this was... I don't remember the date on it.
Right, but it looks like the same phase from tonight.
Yeah, it's about the same phase. I kind of like it in this phase because there's a lot. You get to see a lot of it, and you also get to see the Terminator, where you get to see all the nice craters and everything.
Yeah, that's nice. And so that's if people want to get a fairly entry-level telescope, but hook up their DSLR, if they've already got one, you can get a really beautiful photograph of the moon. Yeah, that's fantastic.
And I don't want to make anybody jealous, but you mentioned snow. It's a chilly 68 degrees here right now.
Yeah.
I got a message on the CosmoQuest share of this hangout earlier from a woman who I'm really hoping it was a typo. She said it was -41 when she was out walking her dog, and that just seems cruel.
Well, that's both the same for...
And not only her, but the dog.
Yeah.
So just one quick reminder, if you're watching this right now, and if you could +1 it, that would be really helpful so we can get a sense of how many people are actually watching this live. Great. Well, I think we probably want to wrap this up. Was there anything else we wanted to look at, or are we kind of done? I think we're done.
Any suggestions? I'm happy to move it over.
You just make it so easy, Gary. I love this view of the Whirlpool. Let's close on this, because this is I think this is my highlight of the night.
Okay.
That is phenomenal.
So the next hangout is going to be tomorrow's Monday. It's going to be tomorrow at man,
Pacific, 3 Eastern, 8 o'clock Greenwich Mean Time, Astronomy Cast.
Yes. So join Fraser and I for a fact-based journey through the universe, and if you want to keep track of this and all the other events that we're doing, you can follow our blog at CosmoQuest, and we also have a variety of different calendars posted, and we hope to see you on the other side, and we'll be doing the same thing on the same Bat channel next Sunday evening.
Pamela and I were on the Skeptic's Guide to the Universe last week, so if you want to listen to that. And we nagged them to try and come on to Google+, so hopefully we'll see more of them in the future. Yeah.
Cool.
Yeah.
We're taking over.
So just a quick view of my setup. This is a picture I took when I had the laptop out there the other day. So you can see that I don't have a lot of really big fancy equipment that some of these other guys have. Just laptop, telescope, a couple USB cables.
Yeah.
Does a great job.
That's all it takes.
Yeah, that's great. All right, great. Well, thank you, everybody. Thanks to John and Roy and Pamela for providing the color commentary, and thanks to Mark and Gary for delivering the telescopes. I was so glad that someone was able to show the view of Mars. That was I was not sure that was going to happen, and I'm really glad we could see the opposition of Mars before it moves further away. So thanks a lot. And hopefully we'll get another view of it on next Sunday, because it's still going to be around, and Jupiter. So Stuart has a broken part in his telescope. So he's getting a new part coming in. So hopefully that'll be fixed, and he'll be ready to go for next Sunday. So thanks to everybody who joined us. Thanks to everybody who's watching, and we'll see some or all of you tomorrow. Thanks everyone.
A lot,
Thank
everybody.
you, Fraser.
Thanks.
Goodbye.
Bye.